We are in the last session of 7.4, and we're going to take a look at some special types of problems where it's going to be much easier to do if we do a technique called factoring out the negative. So we're going to talk about that technique first briefly. If you've taken the time to look at the review section of 6.1, we talk about factoring out a negative when the first term of a binomial or a trinomial is a negative, in which case we are required to do so. Sometimes it can help a great deal to factor out a negative when there is not necessarily a negative in the first term. So let's take a look at something like this. We'll take a look at an expression like b minus a. Well, maybe I want this to read as a binomial. Maybe I want it to look like a minus b instead. So one thing I can do with this is what's called factoring out a negative. If I were to take a minus b and I were to multiply this by negative 1, so I'm putting negative 1 through this, I'm going to get the result of negative 1 times a will be minus a. Negative 1 times negative b will be plus b, which if I go ahead and turn around, I get b minus a. So what I'm going to do with the expression of b minus a is go in the opposite direction. Instead of multiplying negative 1 through this to get b minus a, I'm going to go ahead and factor negative 1 out. Factoring a negative 1 out has the net effect of basically switching the sign of everything on the inside, much like when you multiply through by a negative 1, it switches the signs. Factoring out a negative 1 has the opposite effect, or really the same effect. It's going to switch the signs of everything here. It's going to make this b a negative b. It's going to make this a positive a, which I can go ahead and write this now as negative 1 times a minus b. So we can rewrite b minus a as negative 1 times a minus b. And this technique is going to help us to do some very challenging factoring when we're looking at finding a common denominator. Let's explore this with some questions that we have here. So the first question we're going to take a look at is going to be question 56. So we have t squared over t minus 2 plus 4 over 2 minus t. So we may look at these two problems and say, well, gee, these are really close, but they're not uncommon. But what we can do is the following. I'm going to go ahead and I'm going to rewrite 2 minus t by using the same technique I did over here, which is to factor out a negative 1. I make the 2 negative, I make the t positive, and I'm just going to flip this around and write it as negative 1 times t minus 2. So what I can do with this negative 1 now is the following. So let me go ahead and put that back in the problem. I'm going to go ahead and take this negative 1 and I'm going to move it to the top. And really, I can take this negative, I can just make this on top a negative 4. So it's like 4 divided by negative 1 is negative 4. I'm going to take this negative 1 and move it to the top now. So I'm going to have t over t minus 2 plus negative 4 over t minus 2. So now that I've moved that to the top, or I can make this negative 1 times 4 if you want, but negative 1 times 4 is negative 4. I now have a common denominator. And I can just simply take this, and I can write this now as t. Well, plus a negative 4 will be minus 4. And now I have this t minus 2, and we have our answer simplified. So with this simple technique, we can find a common denominator with some ease and help in this process and work toward getting an answer quicker. So let's take a look at some more questions to continually refine this technique and see how this works. I understand there may be some confusion about this, and I'll be glad to take your questions in class on this point. A lot of students struggle with this concept. So let us continue forward. We're going to go next into question 62. And that's going to be x over 3 minus x minus 2 over x squared minus 9. Now, I'm going to go ahead and I'm going to factor this one first. And when I do so, I'm going to get 2 over x plus 3 and x minus 3. Well, if I'm trying to look for common factors here, x minus 3 looks pretty close to 3 minus x. So one thing I can do, if I factor out a negative out of this, one thing I can do with this now is I can write this as negative 1 times x minus 3. Because when I factor a negative 1 out of this, by making it x minus 3, it gives me the factor in common here. How do I get rid of this negative 1? I'm going to move the negative to the top. Now, you can make this negative 1 times x, but negative 1 times x is just negative x. So I can write this now as negative x over x minus 3 minus 2 over x plus 3 times x minus 3. So this is going to be an important, not trick, but yeah, I guess it's kind of a trick. It's going to be an important technique. That's nicer. At least for math people, it's nicer. To help us get a common denominator and see what work we need to do from here. So we see here we have a common factor in the denominator of x minus 3. We have another factor in the second fraction of x plus 3, which we're going to need to multiply this other fraction by. So here we have x plus 3 multiplying on the top and bottom of the denominator here. So I'm going to rewrite the problem now. Negative x times x plus 3 minus 2 over x plus 3 times x minus 3. Let's clean up the top a little more now. Negative x times x is negative x squared. Negative x plus 3 is going to be negative 3x. This will be minus 2 here. So now we'll have negative x squared minus 3x minus 2 over x plus 3 times x minus 3. Now, you may look at the top and say, well, gee, everything is negative up there. Can I factor a negative out of it? Yes, you can do that. Let's take a look at what that looks like if we do. So I can factor a negative out of that. That's going to be x squared plus 3x plus 2. And that's going to be over x plus 3 times x minus 3. Some of you may look and say, well, gee, x squared plus 3x plus 2, doesn't that factor? Yes, it does factor. And it's going to be, and the two factors here will be x plus 2 times x plus 1 over x plus 3 times x minus 3. So we factor the top as much as we can. Does anything reduce? No, nothing does. So if you were to leave your answer in this form, there's only one problem. You are required, if you have a factor in the first term of a trinomial, you are required to factor it out. So you need to at least write your answer in this form. My recommendation, keep factoring because usually you'll get one factor to reduce top to bottom. But if you leave it in this form, since there's no common factor top to bottom, you'd be okay. But I would write it in this form just in case there is a common factor. So these two forms would be acceptable. This form would lose you a point on the test because you can't have the first term of a trinomial contain a negative. Okay. Now for an answer like this anyway, when you can factor it out. So let's take a look next at question number 66. So this problem contains the following. For x, similar problem here, over x squared minus y squared minus 6 over y minus x. At first, this problem looks like it could be a little complicated. It's a subtraction problem. But let's take a look at the first factor. We'll see by applying the technique I showed you a little while ago. This is going to make this problem a lot easier. y of x plus y of x minus y, I'd really want this to be x minus y. So I'm going to go ahead and I'm going to factor out a negative 1 and then make that x minus y. Then if I want to, I'm just going to go ahead and move this to the top. Now there's two ways you could do this. If you move this negative to the top and you have minus and negative, it really makes this problem an addition. But I'm going to just keep my technique the same anyway. Because what we're after is trying to find common factors in the denominator. That's going to be x minus y. In the first fraction, we have a factor of x plus y in the denominator. That's not uncommon. So we're going to multiply the top and bottom over here by x plus y. When we take a look at minus a negative here, what we're really talking about is adding. So I'm going to make that addition now before I consolidate this together. So this is going to give me 4x plus 6 times x plus y over x plus y times x minus y. So that'll be 4x plus 6x plus 6y over x plus y times x minus y, or 10x plus 6y over x plus y times x minus y. The only other thing you could do with this question, you may see it, is you can factor a 2 out of the top to get 2 times 5x plus 3y over x plus y times x minus y, but it won't yield to any factoring. If you were to leave it in this form, I would probably accept that, no problem. Or you could leave it in this form also to ensure you have all the steps of factoring needed to show your work. We're going to go ahead and show just a couple more questions on this here. We're going to take a look at 64, and then we're going to take a look at, actually let's just go ahead and take a look at question 40. I think this will be enough to illustrate the point. And this is going to be the last question we're going to take a look at in section 7.4. This is going to be 1 minus 6m over 1 minus m to the third minus 5 over m to the third minus 1. So what I'm going to do in this question first is I can get a common denominator for this really easy and kind of simplify this quite nicely. Let's see what we get here. So if I have 1 minus m to the third, I can go ahead and factor a negative 1 out of that. So I can make this m to the third minus 1. Minus 5 over m to the third minus 1. But if I bring the negative 1 up here, here's where I've got to be a little careful, because when I bring a negative 1 to the top, I need to distribute it through everything to make sure I handle it correctly. So here's m to the third minus 1 minus 5 over m to the third minus 1. But the one thing nice about this, we have a common denominator now. We don't even have to worry about multiplying these fractions out. The only thing we have to do now is properly distribute this. Negative 1 times 1, that's going to be negative 1. Negative 1 times 6, negative 6m will be plus 6m. Here we'll have minus 5. That's going to be m over m to the third minus 1. And we'll have here, let's see, 6m minus 6, m minus 6 over m to the third minus 1. And let's see, you may notice here, from here I can factor out a 6 and write this as m minus 1 over m to the third minus 1. And one type of factor we haven't seen yet in section 7.4 is the difference of perfect cubes. And yes, this can show up anywhere, anytime. Recall that one of the techniques I mentioned in section 6.5 when we're looking at different types of factoring is when you see a binomial, you should know what types of factoring to look for. And since these are perfect cubes and it's the difference, we can write this as the difference of perfect cubes. So on the top, we'll leave it as 6 times m minus 1. The factors for the binomial here, and I'm just going to list the factors out. I'm not showing the work. Will be m minus 1 times m squared plus m plus 1. I think I'm correct on that one, but double check my work, and if I'm wrong, please let me know. But we'll notice here that the common factors of m minus 1 are going to reduce, leaving us with a final answer in reduced form of 6 over m squared plus m plus 1. we now have our answer in lowest terms in reduced form.